Hey, it's Kley. Welcome to another video. Today, we are going to start building this tube-driven overdrive pedal. I need to come up with a name with it. If you guys can think of a cool name, please leave it down in the comment section below. But what I really want to do is kind of get my legs underneath me here to figure out how this is going to go together spatially. Because a big part of this build is not the actual build is going to be very simple. It's a simple circuit. But the challenge here is mostly going to be related to how we're going to fit it inside this. So this is the first time. I just got this in the mail. This is the Hammond 1590E. And it's a big enclosure. For contrast, this is like a standard, I don't even know what the name of this size is, but I mean, this is big. It's like two of them in all areas. Even sideways, it's very tall. But I think that's going to be a good thing. So now I have one of my two potential Hammond transformers here. And just so you guys are aware, so this 262E6, this is the one with the 120 volt secondary. The 261E6 has a 250 volt secondary. And yeah, I'm uncertain as to which one I'm going to commit to for the build. I might use them, might have to build two of them. But so let's kind of get a feel for this. Now I'm thinking I'll probably mount the transformer inside like this. We can put the IEC like here, and probably the fuse here. Now I don't actually have a fuse holder. I'm going to need to order one. But let's just kind of get a little bit of a feel for how this stuff is going to fit. Also probably going to want to have a power switch in here. Now one thing is, like, you actually have a lot of vertical space here, so like, you know, you could most definitely have like the IEC here and the power switch right above it. If you want to be thinking a little bit more vertically oriented, that is going to be very doable. But okay, so let's just kind of get a feel for this. Put the switch here. I'll have my fuse in this area as well. Okay, I'm thinking the input and output jacks are going to go, I think it makes sense to me to put them like low, kind of in this area. There's my foot switch. I'm probably going to need to order another one of those as well. I'm going to start making mental notes of the things that I need to order. Now the big question I think is going to be with this tube. I was thinking I would put it maybe in here. I think that would work fine. It's going to be a little bit tricky to figure out a way to get a bracket. I'll need to make some kind of L-shaped bracket. And it'll just be kind of floating like this. Honestly, there's enough space here I could go. I could probably make it fit here vertically. Vertical might be kind of nice. But it might make it harder to actually work on. Well, I don't know. You could always unscrew it. That's interesting to think about. But, because if you mount it, you could also maybe go like this horizontally. Gonna need some kind of spacer or standoff right here that these mounting tabs will screw into that can go into the side of the chassis. You don't want to make it too close, so there might be contact here, but horizontal might be an option. It really doesn't stick out any further than the transformer does. I've got my pots. I'm thinking the pots are going to have to go underneath something. There's just no way around it. And then I could probably put my circuit board here in this area. Yeah, I think it's going to work. There's quite a bit of three-dimensional vertical space. That's one of the things to keep in mind. You know, I could maybe tilt the transformer a little bit like this. Lay my, I've got an old, this is a project board. You know, I probably would cut it down. This one's a little bit too big, but get some kind of turret board, mount it a little bit more vertically. I think it's going to work fine. I do definitely want to have the ability to get in here and modify things as I need. But I think I've got space. So yeah, I think it's going to work. I think my layout's going to be okay. Alright, I've just done some kind of rough laying out with a Sharpie here. You can see I've got my level, my driver gain, the sizzle, and then the base switch, foot switch, LED. Got an output jack here on the left, input jack here on the right. On the top, we've got the on-off, the IC, and the fuse. And that matches everything that we just laid out in here. Now we're going to need to drill a couple holes here on the side for the transformer. And then we'll kind of have to see about the tube socket. It would be kind of nice. Yeah, I mean, I've got room here. I could mount it here. If I mount it here on the bottom, like this, it would be kind of nice for changing the tube out. It does mean that the wires that get wired onto the tabs here are kind of going to be hard to get at, but I'm also not sure how often I'm going to need to get out those wires. And then I could also just unscrew it if I do need to pull this up and modify it. So that's now the only downside of that is it means I'm going to have some like bottom sides of screws poking out here on the top. But I looked at some more images of the page pedals and they don't have any bottom sides of screws sticking out, and I have no idea how he does it. But I'm going to have them, and frankly it's fine. It doesn't really bother me. But yeah, I think actually this size of this enclosure, while it is a big enclosure, I think I'm going to be glad that I have all this space. I think this is going to work fine.
In quite a way, that makes me sit here and think, just get the best guy for the job who can handle the pressures, can handle the force down calls, can handle the media, can handle the locker room, can handle the players, and you just find the right assistants, and maybe you pay them to stay, and if not, you just find the right ones to come next.
Got all my holes drilled out. It's real simple. You just got a couple drills, some different size drill bits. You start with the small ones. A step drill bit like this is really nice. And then I got a Dremel tool with one of these grinder wheels. You know, you've got your holes. The IEC thing was a little bit of a problem just because it's a little bit of a weird shape, but it fits in here nicely now. The fuse fits right next to it quite beautifully. Those two are going to be just fine right there. And so, yeah, these holes are all ready to go. I am going to take everything back off and try and paint this thing. So that'll be kind of an adventure. Honestly, usually I'm a little bit more pragmatic, but I'm going to try to paint this puppy. So let's give that a shot. All right, the enclosure has been painted. Certainly not perfect. There's some little scratches and blemishes that are showing through. There's some spots where the paint's not super even. However, it's a nice satin black, and I think it's actually going to work just fantastically. So we're going to start assembling some stuff here soon. All right, I've got it painted. I had a little bit of bubbling here. I don't really know why. The clear coat and the base coat didn't play well. It's from the same company, but frankly, I don't really care how it looks as long as it sounds amazing. So I've got all my hardware bolted and screwed on nice and securely. And we are ready to start wiring this puppy up. Let's do it. All right, quite a few screw and nut turns later. This is where we're at. The transformer fits in here fine. It's definitely a little bit tight. There's some space back here. Maybe could have used a little bit better. Gets pretty tight here on this base switch. But yeah, I've got my power section here. I put my LED in this area. This is a 120 volt LED. I'll just run in with the power supply. Transformer wired in. Got my 3 pots. The tube socket's fine. I've got these spacers on here to kind of elevate it. So I think what I'm gonna, and then I've got this vent right here to keep the heat out. I do have an extra hole on the top. Again, try to keep some heat moving out. Got my switch, my input and output jacks. I mean, this thing is ready to start wiring up. Not sure yet how easy this will be to see, but I have the power supply side wired up. Got the IEC jack, The middle is solo grounded to a lug which is bolted onto the chassis. This right side here is going directly into the power transformer. The left side is going into the switch, into the pilot light, into the fuse, into the other side of the primary of the power transformer. So, in theory, if I applied 120 volts computer cable into this thing, I should now get secondary voltage here under these two windings. Now, one thing to think about here with the filaments next, I'm going to tightly twist this pair of green wires, and then I do not see any kind of center tap here on the filaments, so I'm probably going to do a virtual center tap. So we'll have to figure that out. Maybe I have to add that to the board, or maybe a terminal strip. I'm not quite sure yet, but yeah, we're making progress. All right, let's take a look at this power supply wiring here on the primary side. We've got this IEC jack here. This middle terminal here is the ground, and it goes to this wire, and then it connects right there onto that lug, which is chassis grounded. Then this wire here on the left is your hot, which goes to a switch, to a 125 volt pilot light, into a fuse, into the primary. Then the other side of the primary goes over to the neutral. So now if I plug 120 volts in to this IC plug, turn the switch on, get a 1 amp fuse in, we should get voltage here on the secondaries. All right, we're trusting the process a little bit on this one. I got my input wires to my foot switch jack. I'm gonna wire leads to each of these pots and to my base switch. And then I've got these spacers. And then I've got my circuit board, my turret strips. So it's coming together. All right, power supply is wired. I got leads coming from all the pots and switches, and I've got my turret board mounted. It's pretty simple. Just took one of these screws, ran it through the bottom. I got one of these nylon spacers. I've got a couple different sizes, and I picked the one that fit the best. And we just run a nut on top, and it's on there nice and secure. So now we start building this thing. Making a little progress here. These green wires are my 6.3 volt heaters. There's no center tap, so I put down a terminal strip here, and the middle part is grounded, so each side has a 6.3 volt tab on it. And then I'm running two 100 ohm resistors to ground to create a virtual center tap. And I'm going to run from here into the tube. Making some more progress. I put in a new switch because my previous one was not really cutting it. I think the red part was kind of melting. Just it was too old. So if we follow this white wire here from the input jack, this middle terminal, when the effect is on, it goes through this yellow wire up to this joint. There's the 1 meg to ground going up. This is my kind of ground plane right in here. You can see this wire that's jumpered across the 3. Then we got a 22K going to the white wire to the grid. Then I got the blue is the cathode. Coming to this point, there's our actually I use a 2.2K bias resistor to ground. And then the blue wire here goes up here to my base switch, which has a green and a yellow wire tucked in there. Coming to this point, so I've got the black capacitor is 10 microfarads, that's for full frequency, and the green is a 0.47 microfarad, which should be a base cut, and they're both grounded on the other side. So, starting to make some progress. You know, piecing through these wires is a little bit challenging, but we are getting there slowly but surely. One other note I want to make, I've got my diagram here, and whenever I make a connection, I try to exit off, and then I also have a copy of the schematic, so I'm trying to keep myself organized. In the past, I would just build off the schematic as needed, but with this, because it's such a tighter build, and I only have 20 terminal rows, I had to be a little bit more planned out, so this is how I'm managing it to make sure I'm staying on track. Got this thing mostly wired up. It all fits. The wires all connect. I only got one open terminal here, So I counted everything out well. I did do the layout a little bit differently once I got in there and started making stuff. Keeping track of both the layout and the schematic was kind of chaotic, so I ended up really just focusing on the schematic because that's what I'm used to and I trust it. So I ended up, every time I made a connection, soldered it in, I would put a little blue X. So that's just how I kind of kept track of it. I will try to update the layout, but I would just say the layout is secondary to the schematic. I always would refer back to the schematic first and foremost. Now the last thing that I'm thinking about is grounding. So what you need to think about is I've got an IEC power plug that's got a safety earth to chassis, and you need that for safety purposes. The thing is not safe without it. But that means I've got a path to ground. The chassis is grounded through the IEC plug, which will run into a 120 volt power cable, which will run into the wall. Now I also am going to plug a guitar cable into the into the output that's going to run to an amplifier. The shield of this output jack is also going to ground through the amplifier to the wall. So there's possibility of creating a ground loop. You've got two paths for ground. One through the IEC and one through the shield of the output jack. So I'm going to leave a link down in the description below, but I've been reading about ground loops, and Merlin Blencowe has an article about grounding. He's got a little grounding circuit that I'm going to try to implement. But basically, all of my grounds in the circuit come to this green wire right here. I've got some here in the power supply. I've got a couple up here, like from the pots. I've got some down here and from the cathodes and the pots, all need grounds. But they all come to here. So I think the move would be to, first of all, isolate these jacks. So that removes the possibility of the ground from the cable. Now to isolate these jacks, I'm going to need to get some isolated washers, because right now the metal from the sleeve of the jack is bolted into the chassis. So I'm going to need some kind of isolation washer there to prevent that connection. Then I believe I got to use this ground lift circuit. Then if the jacks are isolated, I can run these two wires to this ground node. I got a couple open spots down here, and I got this green wire that I can run to my ground lift circuit. Okay, now that I've got this thing wired up, we're going to start up with some initial startup procedures. I've got a light bulb current limiter plugged into the wall. I've got an IEC cable going into the pedal. I have a 1 amp fuse currently installed. Now, in the long run, that might be too high, and I might want to drop it down. This 12AX7 isn't going to draw a tremendous amount of current, but it's better than nothing. So, I've also got my voltmeter out. I'm set to AC volts. I don't have a tube installed, so all I'm really looking for is to figure out if we're getting voltage on this thing. All right, let's start with... All right, now that I have the pedal wired up, we're going to begin some initial startup procedures, see if this thing was done correctly. I did do a once-over review of the schematic and my connections, but it is certainly possible I've missed something, so we want to be safe. If you just plug the pedal in and plug it into an amp, that's not a great idea. You want to do some startup procedures. So I've got a light bulb current limiter. If you don't know what that is, Google it, but I'm not going to go into that too detail. So the 120 volts comes into the light bulb current limiter. Then I got my IEC cable going here into the pedal. If something goes wrong, this will light up really bright. I've also got my voltmeter here, testing some voltages, and I'm set on AC. So we got 120 volts AC coming in from the wall. We want to track that throughout the pedal. Okay, it does not appear that I'm getting the high voltage AC off the red secondary winding. So let's investigate. Okay, I'm getting 120 volts on the hot input from the power cord. Neutral's at 0. The ground is at 0. So then we go into the switch. Okay, so we're getting 120 volts out of the switch into the pilot light. But we're not getting voltage into the fuse. So I think the problem is with the pilot light. Okay, I think I figured out my problem. It's this pilot light. This is from Hoffman's website where I got it. It's a 120 volt AC neon lamp assembly. Just solder 2 wires to this lamp. One goes to the neutral white power cord, the other goes to the hot black power cord after it comes out of your main switch. So, on my IEC plug, this furthest right connection is going into the transformer, and then also a second connection going to the pilot light. Then the hot connection on this one right here on the IEC plug goes to the switch, goes to the fuse, and then this other side of the fuse, which goes into the power transformer, is where I bridged the other side of the 120 volt AC lamp. So a little bit of a funky pilot lamp, kind of unique to just this one I've got, but I do actually remember having trouble with this the last time I did this too, but I should be good to go now. So let's try a power cord. Okay, the switch made the light go on and off. That's good. Now let's check for AC voltage. Okay, we're on the other side of the fuse. There's 120 volts. Okay, that's good. So my power input section should be working fine. Let's check for 6.3 volt filament. Okay, 3.8, that's a good sign. Also, the draw on my light bulb current limiter is basically nothing, which is accurate. There's basically no current being drawn through. So then the only other secondary winding would be the high voltage. So let's try that one. I think we're looking at something above 120. All right, well that one part has 74 volts AC. Let's check to see if we're getting rectified DC voltage. Okay, 198 volts DC. I think that's what I want. 75 volts AC on one of the red wires. And 73 volts AC on the other side. So, okay, this doesn't look bad. Everything looks pretty good, actually. All right, let's take this, stick it on DC. Let's see about the plates. And 197 volts on that plate. So we're getting high voltage. That's good. All right, I just got done taking some voltages. My power supply is giving me 72 volts AC coming out of each of the 2 red high voltage B+ leads. So it's 72 times 2 is your voltage AC coming out of the 2 red wires. Then after the diode rectifiers, it's 192 volts DC. Then after the filter cap and the smoothing resistor, 189 volts DC. That feeds over to the plates. So the input tube V1A is 130 volts DC on the plate. Got basically no voltage on the grid. Just a couple of millivolts, and it kind of bounces around a little bit. Then 1.27 volts DC on the cathode. Those voltages are pretty much identical on V1B. So those voltages are kind of what I was hoping or expecting to see. So I think I'm going to plug this thing into an amp. Let's see how that goes. Okay, I do want to make one last comment about my grounding scheme. So this is probably something that is going to need to change or adjust, but for now, what I've got is the following. So I've got my main, the IC plug, has a safety earth to this bolt right here. It is hardwired so that if this chassis ever does come into contact with voltage, and you got to remember, through the input jack, my guitar strings are going to also be sharing ground. So any voltage that comes onto this chassis will be connected through this point to the ground earth safety earth connection of the IEC jack and go to the wall, the safety earth in the wall. So that's my safety feature. Then I technically currently have two ground points. One is right here. I have my filaments, the 6.3 volt filaments, going to a artificial center tap through some 100 ohm resistors to this ground point here on the chassis. Then lastly, all of my other ground points, so like I've got a ground point here for my diode rectifiers, I got a ground point here for the filter caps, got a ground point here from the pots and the circuit grounds, I got one back, I got a ground node up here. All that ties into this single green wire, which goes to this input jack, and that ties this into the chassis at this point. So I'm kind of mimicking a grounding scheme that you would see in like a tube amplifier. Now it's possible that that might create a ground loop, because if we think this through for a second, our IEC plug right here is going to have a connection to the wall, to earth, the ground. Also though, this connection here is going to send an output cable into a guitar amplifier. Well, that input jack on the guitar amplifier is also going to in some way lead to the safety earth that's plugging into that amp's chassis. So between this ground point and this ground point, there could be an earth loop connection cycling the current between those two different locations. So it's possible that this could generate a ground loop. Now in theory, there's a couple things that we can do, and I probably may look to do. The first would be to isolate these jacks. You can either buy cliff jacks, which are the body or the housing of that is made out of plastic, and then these jacks are not grounded by being screwed into the chassis. Second option, you can get some washers, some specialty washers that actually add a little bit of a shoulder on both the inside and outside that isolate it from ground. Additionally, after that, I'm probably going to look into installing a ground circuit. So this master ground star point would instead go into a ground loop eliminator circuit. And we'll cover that more in a second. But I got that from Merlin Blencowe's book, as well as some really helpful discussion from TDPRI. But I'm too excited for that. I'm going to plug this thing in, and we're going to see what happens. Alright, this is just the guitar plugged into the amplifier. Alright, now I'm plugged into guitar cable into the pedal into the amp. I'm definitely hearing a ground loop buzz at this stage.